Hello and welcome to Morehouse's Math Menagerie. Today we're going to talk about confidence intervals for two means with paired data. Trace metals in drinking water affect the flavor and in an unusually high concentration can pose a health hazard. 10 pairs of data were taken measuring zinc concentration in bottom water and surface water from randomly selected wells in a specific area. And here in this table at the bottom, we have the data from those wells. So this is well 1, 2, 3, and so forth. Now, since the data, both of these data values, were taken from the same well, they are not independent. Previously, when we looked at means, we looked at the mean of bottom minus the mean of surface. We would take the mean of the bottom, mean of the surface, and we would compare those two means. We cannot do this here because these samples are not independent. So what we're going to do instead is look at the mean difference for these wells. What that means is we are going to subtract these two data points for well 1 to create a difference down here. You can see that difference would be 0.015. Those are horrible zeros, my apologies. And we would do the same for the rest of these, and then we will analyze the mean difference, the mean of these differences, as our problem. Let's see what that looks like. So first off, we're going to put the data into list 1 and list 2 into our calculators, just like we normally would for a difference of two independent means. But here, as I said previously, since we're paired, after we have list 1 and list 2, we can highlight L3 and we can type in there L1 minus L2 when L3 is highlighted. By pressing enter, the calculator will find the differences for each of these, doing the bottom minus the top water measurements for these 10 wells. So this single data set here, this list 3, is what we're going to do our analysis on, just these differences. So we're going to say that we're going to construct a 98% confidence interval for the true mean difference in bottom and surface zinc concentrations. Notice I didn't say true difference of the means, I said true mean difference. And then notice I also indicated the direction I'm subtracting. I'm doing bottom minus surface. It is not necessarily required that you list this out, but I like to add it. It's a little bit in the notation of bottom and surface that we're doing bottom minus surface here in our state phase, but I like to say explicitly that it's going to be bottom minus surface, just in parentheses after the end of the sentence. This is a two-sample t-interval for a mean difference, or you could say mu sub d. Mu sub d is common notation for a mean difference. We have a random sample of 10 wells. We have a 10% condition is met because 10 times 10 is 100. And then for normality here, we don't know anything about the population of the different zinc concentration in wells, and we have a sample size less than 30. So we're going to have to make a box plot here. Oh, sorry, let me clear that off. A box plot here, and you'll note that we have kind of a big square here in the second quartile, and we have kind of a big whisker to the right here in the fourth quartile, but overall, no major skewness together and no outliers. So we can make a statement that the distribution does not show any major skewness or outliers, so a T procedure is appropriate. Now, I will point out that if this square here was moved over, so like this was the median here, and we had a large square and a large whisker on the same side of the box plot, then a T procedure would not be appropriate. To run our data here, since we're using just the differences, we're going to calculate it the same as we would for a one sample T interval. So we go to T interval in the TI-84. We have our data in list 3. Our confidence level here is going to be 98%. We can hit enter, and we get this lovely interval over here, 0.03376 to 0.1274. Please remember that when we have paired data, the calculations look the same as if we have a one mean confidence interval. To conclude, we're going to say that we are 98% confident that the true mean difference in bottom and surface zinc concentrations, again, I put that bottom minus surface in parentheses, is in the interval 0.03 and some change to 0.12 and some change. Thank you for joining us. I'll leave you with this quote by David Brinkley. Have a great day.